You guys hear me? Oh, we got an echo, huh? Echo now? Hello?
You sound better than yesterday.
Oh, I don't.
Oops. Hi, can you hear me now?
Yeah, I can hear you fine.
Yeah, you sound better.
Okay, here. Okay, let's just try. All right, did I get rid of the echo? I hope.
Yeah, that sounds good. You sound better.
Okay. All right. So now you guys can hear me. Okay, perfect. Because we're going to keep using two computers here. Okay. So I think what I want to do is finish up assignment 3 and 4 today. I'm totally going to assign the pre-test, the post-test, and the weapons for chapter 6 at this point today, but I'll give you guys a week to do it. No problem at all. You have till Sunday of this week on the exam now. Just chapters 1 through 4. Nothing we're doing yet. And then I wanted to go back and work on the worksheet that we were sort of in the middle of before I explained assignment 3 and 4. And then if we have time, of course, we'll do some review of chapter 6 before we get into anything new like chapter 7. So that's just sort of the general game plan agenda. I'm thinking walking through this really helped you guys. So what I wanted to do is I think we left off on the percentages of the hand calculations. And then in terms of what it's asking for the hand calculations on the second part of the assignment, I was going to walk you through that. I was actually going to show you something really cool. It blew my mind the first time. I hope it blows yours. How we can import data from Excel directly into SPSS. I know I said that we can do that, but now we have a file that I have ready that I can show you that, as well as might review the SPSS calculations to give something that you guys might want to have handy, because you're going to want to refer to it. I mean, I have them in front of me too, but the formulas for chapters 3 and 4, I would probably keep that handy. I'll show you where that is, just so you know. I would definitely recommend. It'll just make it easier as we're walking through stuff today if you have this available. That's literally right here in General Resources. If you guys can see my screen, I think you can. If you can't, you got to tell me. And then formulas. And all we're really using on this assignment is literally chapters 3 and 4 formulas. So I would just maybe keep that handy somewhere. If you can print it out and look at it not on a screen, that would probably be helpful. Looking at it on a screen is absolutely totally fine too. You guys, something to look at and refer to. Because when we look at, later we're going to talk about the mean, the variance, and the standard deviation as what the assignment's asking. And just having it in front of you would be important. So just like something to refer to. So let me go ahead and do a new share. Let's go back into the Excel that we were working on. Okay, so we were calculating, I believe it was percentage, right, guys? So the first one was 1%. So the formula is always for percentages. It's kind of like frequency, but it's the number of times the thing happens over n, or the population, is a good way to remember percentages. So it always works. So the first thing we did, we took 4 divided by 371 yesterday, and then we got 0.0100, and there was a bunch of numbers after it. We moved the decimal over twice to end up with 1%, and that's where we left off. So the next thing that let me do a new share so you guys can see this. The next thing that we would be doing here, guys, would be we'd be taking 8 and dividing it by 371. So is everybody following me in terms of how we do just percentage? We're going to deal with cumulative and rounded percent and all the pieces of this assignment first, but I just wanted to walk through percentages. I thought we could do it like last night. But before I do that, is anyone lost? And does anyone have any really burning questions, things they want to ask, like they don't feel can wait till the end of class, concerns on assignments, how you're doing in the class? I don't mean like specifically like your grades. I want to talk to you, any of you, about that privately if you have a concern. But I mean like general questions on assignments, due dates, anything we're doing, or what I just walked you through before we walk through the percentages, guys. Talk to me. You can alternatively give me a thumbs up or something in the chat if you're good to go and you're ready to go through percentages. I'll give you several seconds or a minute or so to respond. If not, we'll go through percentages, guys.
I'm going.
All right, so we should be good to go from what I can see in the chat. If I'm mistaken, let me know. The biggest thing you guys can do, as I mentioned this probably before in the past, just please communicate with me. If you're totally stuck, you got a question. Part of the reason we're walking through this assignment, we walked through it last class period because at least one of you, I believe it's actually a few of you, reached out and were just concerned about walking through how to do this. All right, so if we take, within Excel, we're going to take I-15, which is this. We're going to divide it by our N, which is 371. What do we have for our next percentage? Type it in the chat, use your mics. Let's do the math together to practice doing percentages. We're doing the percentage of this against the 371 all the way up, guys.
$2%.
Perfect. Now, the only reason that I'm not getting 0.002 in all those numbers is because I think I showed you this last night, guys. I hit the percentage button right here on formatting the entire column. So yeah, that's totally it. Nice. Let's see, this will fill up. It should fill. See if that works. All right, so the next one would be, of course, 19 divided by 371. Whoever gets it first, put it in the chat or use your mics.
5%.
Yep. That's totally it. So the next one's going to be 36, which is going to be literally this right here against the N. So it's just a percentage of all this for your frequency against 371. Whoever gets it first, tell me, and we'll see if you are.
9%.
What'd you have?
9.
I didn't hear you. What was that?
9.
So I got 10, but maybe it's a rounding error, or
Yeah.
maybe you're not rounding.
Yeah, I did it round.
I would take 9% on that. Let me just do the math real quick in the calculator to check it against Excel. So if we take 19 divided by 371, I get hang on, 19. Wait, that's 36. 36 divided by 371. I get 0.97%. So my column rounded up. I would, for this, just the sake of what we're doing, I would probably just say 9% so that we get to 100 up here. So I would just say 9. We'll round later. Maybe we'll put a note here, 0.7%, just to have that because it automatically rounded. Okay, so the next one's going to be 45, which is all the frequency, against 371. What do you get? 12, Lewis? Yeah, nice. Probably wasn't rounded at all. That makes all do this formula. Okay, so the next one's going to be 58, the frequency against the n, f over n. What do you guys get? 15, Maddie? I get 16, but my guess is it's probably really close. We can put a note here, 15. Let's see. 58 divided by 371. 15.6. So maybe I'm just putting the note here. So yeah, I'll take either because we're not really rounding, guys. And we're going to round in the next column. So all right. So what about this one? This would be 69 divided by 371, or percentage. You have 18, Maddie. Okay, and Lewis is 19. So I'm just telling the formulas what to do. Let's see if it rounds up. So I get 19, and you probably got 18.5 or higher, I would imagine, right? Do the math here. 69 divided by 371, 18.59. So if you have 0.5 or higher, you typically round up. We'll put 18.59 right here just for just noting it. I'm just going to make like more exact percent on this side. So yeah, you guys are both right. If you round, Lily's right, Lewis is right. If you don't round, Maddie's more right. But the rule, just if you don't know or it's new to you, you go ahead and admit. Ryan, I didn't see you there, Ryan. The rule is always whenever it's 0.5 or higher, you round up. If it's 0.4 or lower, you tend to round down. So so this next one is going to be, of course, 35, the frequency, divided by the n, 371. So in that case, you get, what are the percentage? Are you saying 9, Maddie? Let's see if you're right. Yeah, that's what I get too. So my guess is it's 9 or 9.00, but it's probably pretty close to 9. Okay. So the next one is going to be 32, our frequency, divided by our n, 371. So if you do that, what do you guys get? 8.62. Let's see. So that makes sense. And what it does, it rounded up. We'll put the 8.62%. Put it in the notes. So Excel is sort of auto rounding, but 8.62 is definitely more accurate. And again, when we're doing percentages, we're not doing cumulative percentage. We're not doing rounded percent. The numbers in this column are really what we're looking for. We're going to round it in a moment. We'll walk through that as a group. Okay, so this next one is going to be 29 over n, which is your 371, your frequency over your things. What would that one be, guys? 7.81. So if it's 7.81, it's probably going to auto round for me because it's Excel up to 8% because it's 0.5 or higher. So that's the rule, and it did. And we will put 7.81% right here because that's really more what you should be writing down. Right now we're just looking at the exact percentages. We're not really rounding. This is likely what we're going to do with rounding in this column, but we'll walk through it as a group. All right, so 27, your frequency, divided by your n or your 71. What do you guys get? You get 7.27. So in this case, 7.27, because we're below 0.5, it's probably going, or 0.50, or you look at it, it's probably going to round down, which it did. It stayed right at 7. And lastly, our last one is 9 divided by 371. So what do you guys get? 2.42. So that should round us to 2%. Rounds, yeah. I'm going to say 2 point, here, 2.42%. And this was 7.7%. Are there any other ones that you guys see in here that could be more exact that I'm missing? That's the percentage exact. Now we're going to talk about cumulative, but before we do that, let's just check something out here. So these are, this goes all the way to 100%. If I take all these columns and I just sum them, I should get 100%. Okay, great. That makes sense. Are there any ones here that should be more exact, guys? Tell me if there's not. I'll just move it over. Actually, is that right? Okay, this would be so. Let's see. Let's just actually watch what fill it in, and we'll just see if there's anything that's off here. So 12, 5, 2. So if I sum these, well, let's also give me 99.01. So something got rounded up or rounded down here incorrectly, because this should really be like 99.9. So can someone tell me which one we missed? See, 18.5, 8.62, 19. If we take this one right here, we round, I got 100. I just summed them. I just told Excel to sum for me. Sum. .15. That's what that 2.15 for that first one. See, there we go. And what's the other one? Maybe there's another one in there, Maddie. There's probably one that's not exact here. I can tell you also. All right, so 4 divided by 371 is 4. This is actually 10. It's actually point. This is a 1.078. More like not 1.078%. See, now it's a little more accurate. Now we're getting much closer numbers. 5.12 on the 5%. Yeah, there we go. 5.12. Okay, so there's like another one missing, which was like the most accurate ones. Someone else know what the other one was. One? 19, maybe? Let's see if that's 9.43. Yeah, because this one would be higher, right? 9 point, we would round it down. Yeah, 9.43%. See, now we're getting real close. And then there's probably one more. Maybe it's like, this is probably what, 2.221%, if I were to guess. Maybe you guys can tell me if that's correct or not, or this is maybe 2.31% or something. I bet you that's, I'm getting pretty close, 3.4% maybe, or 2.35%. Is that right? 2.15. 2.15. Okay. So what's this one? The 5. The 5 needs the last one. 5.12. Is that what I have? 5.12. I don't know why that automatically ran. It's not supposed to be. That would be it, because that would take us to 100%. Just to like visually look at it. Okay. So our worksheet asks us to do, what is the next thing here? It's a little smaller, so I can sheet here. All right, last assignment 3 and 4. Next thing it asks us to do is cumulative. Okay, so we did pretend. Now we want to do cumulative percentage. So the cumulative percentage is done a little bit differently. It's kind of like the frequency percentage that I no, it's fine. It's fine. The frequency percentage. So back, if you guys, hopefully you guys still see my screen. Let me see if there's anything that I gotta look at. Yeah, 9.7. Yeah, you got it. Okay. So yeah, so we're getting it right up. So these are like, so the percentage really be exact. So if we want to do cumulative percent, what cumulative percent is basically, put that right here. Would mean that basically we are summing these. So this one would be like 1%. This would be like 3%. This would be 5%. And basic 5. No, this would actually be 8%. Because it's cumulative, not 58, 8%. Because it's cumulative. So basically, what I'm doing is I'm going equals, and it's always going to be Q14 or Q13. Q13. No. R13. P14 plus O plus O, and that is O13. See, that's what we're doing. So then basically we stay with just the exact percentages, assuming they're all correct. They're incorrect, you guys just trim. So the next one, I'm going to add it to the previous percentage cumulative percent. We go up the column. So it'd be up. That'd be 29.7. And then the same thing would be like this. So hopefully you guys are starting to see the pattern. So maybe somebody can tell me what the next percentage would be for cumulative percent for this row or this column. Use the chat or your mics, guys, either way. So remember, we're going to keep adding, and we're going to work up to 100%. We should end up at 100% when we get to the top. So what is this one if we add this to that? What do we get, guys? Yeah, we're adding. Yeah. What are we adding? We're starting with the bottom percentage here. Maddie, thank you for asking. So I'm adding 1% to 2% to get 3, 3% to 5% to get 8. 8 plus 9 is 9.7, 17.7%. 17.7% plus 12% is 29.7% plus 15.6 is 45.3%. So we're adding each percentage to the next percentage, which is how we do cumulative percentage. And as we go through all of the frequencies of all of the numbers, we are going to end up at 100% cumulative percent. And if we don't, then we might have a rounding error. Does that help clarify that? 60.9. So let me just formula in here, and I have to go fill up. What do I get? Yes, 3.89, 60 point, yeah, 63.89. What you put? You put 60. Yeah, 63.89. Yeah. I'm assuming that maybe just the math was off or you rounded or something. So what's this next one? That's what 63.89. What's the next cumulative percent if we add 9% to it? assuming that that was exactly 9 and we didn't round. $72.89, Maddie and Lily, is what you're saying. Okay, let's see. So that makes sense, just doing the math in my head. Yeah, 73 point. That's probably rounding, because that's, I guess, 73. So maybe it's because I said 9. Maybe it's supposed to be a slightly different number. Which if I look at the chat, that's probably correct. If I go back to the chat, yeah. You guys are on it. Okay, so then what is, yeah, 72.89. Yeah, and then what was 9%? It wasn't 9%, right? It was like 8 point something for the exact. Is that right, guys? Calculated that too. So that, let's see, so it was 9.43. Yeah, that's why. So if we go back and I say, okay, 9.43, and that shouldn't be doing that. Well, you get the idea, I think. All right, so this one, if we add to the next one, 8.62, what do we get? Should be right about what you guys get. Do that. So you get the math on your own. $81.51. Yeah, that's probably about right. Let's see. Yeah, yeah, because because I have the exact ones and I'm not rounding up or down. So yeah, I have 81.94. Yeah, that totally makes sense. Okay. What about this one for cumulative percent? What would the next number be? Eighty-three, 89.32. That sort of makes sense in my head. Let's see. Go up. 89.75. Yeah, close enough for horseshoes and hand grenades when close counts, right, guys? Okay. So what would the next one be? For cumulative percent from 89.32 or 89.75. I probably have, but I didn't round. What do you guys think? What's the next one? 96.59. I get 97.02 if I was rounding. That would kind of make sense. So yeah, 96.59 is still correct. And then what would our last one be, which should get us pretty close to 100 for cumulative percent? 99.01. Oh, I got 99.44. Yeah. So somewhere I probably could have typed a more accurate percent, but we're pretty close to 100%. So we're definitely doing this correctly. So if you go back and you do your frequency over your total, like F over N, somewhere there's probably a calculation that could be a little bit more accurate. Like I want to say this was like 1.087 or something. So this might be like more like 1.1% realistically, or something like maybe 1.2. And then it might get us a little bit closer. But yeah, that's totally it. So does everyone get a sense of what cumulative percent is? Questions, thoughts, concerns before we address the next part of the assignment, guys? Or give me a thumbs up if you got it and it's totally making sense to you. Got it. Okay, cool. Awesome. You can agree or disagree with your colleagues. If anybody doesn't get it, it's totally okay. If you got it, that's great too. But spend as much time as we need always help you guys out so that all the information sticks and you're like, okay, cool, I had a good class. All right, so the next thing that we're going to look at is rounded percentage. So rounded percentage is pretty easy. Hope you guys can still see my screen. Rounded percentage. So basically this column is rounded percentage, but just so that it really sticks, guys, maybe what we can do is you can all tell me in the chat or with your mics why these are rounded percentages, like why I rounded up to get here. So maybe calculate or tell me what the real number is for the exact, if it's listed or not, and then tell me why you rounded the percentage up or down, because that's what rounded percentage is. So for one, for the first one, 4 divided by 371. Actual one is 0.1078176 is the exact percentage number you get. So we round that to 1%. And tell me why we round that to 1%. We move the decimal over. If I did a new share, a new whiteboard for rounded, okay. And the first one, we take 4 divided by 371. That's the number over here we had. We have 0.0107861. That's the actual percentage, not the percentage. Move the zero over, the decimal rather, over twice. So we have 1.07861%. So why is this 1%? You can tell me the rationale as to why we round that down to 1%. Chats or mics, either way. Okay, so we always go to the right of the decimal point in percentages. That's what we're looking at. So if it's 0 to 4, you're going to round down. If it's 5 or above, or 5 to 9, you're going to round up. So this tells us to round down. We usually go 2 decimal places over. So this would 7 might tell us to round up. So we can even go as far as saying, okay, that's 1.1. But again, 1 decimal place over, going back to this rule right here, that's going to be 1%. So our rounded percent is 1%. The next one is 2%, which was what, 8 divided by 371? So 8 divided by 371, that is 8 divided by 371. That's 0.2. I'll write that on the whiteboard. You guys can see the whiteboard. I hope you guys tell me. So the next one, the exact percentage is 0.0215634. So move the decimal over twice to get the percentage. So we have 2.1563334 percentage. So again, 0 to 4, that's a 1. So we're not going to round. To 5, we'd round up. So maybe we could say this is 2.2. But again, we have the 0 through 4. So that would be 2%. So the next one, I'll let you guys do. So we have 19 divided by 371. So 19 divided by 371. So do that on the calculator. And we have 5% rounded. But our exact number is sure. Our exact number is 0.05121294. I think you guys are pretty clear about how we get to 5%. We move this over 2 places. We have 5.12, all that. So why do we round down? Can someone type it in the chat? Why is this 5% and not 6%? Based on what I just showed you guys. Use your chat or your mic, or if this is all very clear to you guys on how to round, post that in the chat, and we'll do the next thing. I just want to make sure I spend the time to explain it, guys. Yeah, 0 to 4 round down. That's totally it. All right, so the next one is, nice job, Maddie. The next one that we have is Add here. $36 divided by 371. And we got 9.7. So someone tell me why 9.7, assuming that math is right, you're totally welcome to check it. Why would 9.7 get rounded to 10% for the rounded percentage?
We rounded up.
Yeah, because it's above, it's 5 to 9 or above 5. Yeah, that's totally it. What about 45 divided by 371 is 12.12938. So what's the rule for why would 12 get rounded? The 12% get rounded down? What would the rule be? The reason? Yeah, 0 to 4, because we have 12.12. 1 and 2 are below 4. Yeah, that's totally it. 15.6. Why does that get rounded to 16%? 5 to 9 round up. Yeah, that's totally it. Kids are getting it. All right. 18.59 rounded up to 19%. Type the reason or use your mics. Why is that when you round it up? Just for drill guys. Yeah, round up. Same reason. 5 to 9. Okay, 9. This is what, 35? 35 divided by 371. The exact amount is 9.43. So 9.43%. Why is that rounded up? Why is that rounded to 9%? Round down 0 to 4. Totally correct. 8.62. Why is it rounded to 9%? Yeah, 5 to 9. Yeah, that's totally it. 7.81. Why do we round it to 8%? 5 to 9. Yeah, that's totally it. 7.81. 7.27%. Why is it rounded down to 7%? 0 to 4. Yep. And the last one, 2.42%. Why do we round that down to 2%? Yeah, 0 to 4 again. Yeah, it's got it. Okay, cool. All right. So if there's any questions, totally okay to ask, guys. All right, so we did rounded percentage. Okay, so then we want to do the cumulative rounded percentage. So that's done a little bit differently. Cumulative rounded percentage. So the rule is what you guys want to know on this one for the cumulative rounded percentage. All right, clearly it's 100%, right? Because that's added this column. But if you were making, if you had a few more of these, let's just for the sake of like making this rule just a little more visual for you guys, let's just say for argument's sake, I had rounded and I had 3% right here. And I had 2%. Let's see, give a better example. Say I had 1% right here. No, that's not what I want. Yeah, let's say 3%. Yeah, there we go. So for cumulative rounded percentage, how it works when you have a group that you're rounding up or down and you exceed 100%, what you do is you round the last one up or down to get to 100% when you're doing cumulative rounded percent. So if I'm adding this way, of course it would be this one, okay? But if I'm adding down this way cumulatively, then what I would want to do is I want to round that to 2% because we can't exceed 100%. But when you're doing cumulative rounded percent, it's always the last one to get you to 100 that you're going to round up or down in percentage. That's what that rule is. That's what that means. So cumulative rounded percentage. In this particular exercise, they were nice and neat, so there really wasn't a need to apply that rule. But if you ever had that problem, that with exceeding north of 100%, you round the last one close to the summation or the cumulative amount. You don't go back and round them all. It's just the last one close to 100%. Hopefully that makes sense. I feel like the rule's pretty straightforward. If I'm not explaining it well, by all means, please tell me, guys, or maybe give me a thumbs up. That's all making sense.
Can you repeat it?
Yeah, absolutely. Anytime you have a group, and I can put the Excel back up here if that'll just sort of visualize it for you guys. So in this particular example, why is that not letting me share? What the heck? Oh, maybe I just. In this particular example, our rounded percentages were all these. This right here was clearly cumulative rounded percent. Now, the reason this was cumulative rounded percent is because this was the accumulation or the summation of all of our rounded percentages. And it was nice and neat. And it was 100%. And that's really all you have to do for this assignment. But the rule that I'm explaining to you guys is just for the sake of argument, let's just say these numbers weren't as easy to round, or there was some unusual stuff with these numbers, okay? Or we had more odd numbers or something, and it didn't add up nice and neatly. And just for the sake of argument, let's just say this last one was 3%. Now we have a cumulative rounded percent of 101%, and you can't exceed 100%. Like, that's not a thing when you're dealing with percentages. So the way to address that is a number closest to the cumulative rounded percent that makes you exceed the 100%, you round up or down to address it. So in this case, it would be back down to 2%. Now, I'm just going to modify these for a moment to give you guys like another example. So if I had 7% here, I had, let's see, 5% here. And let's say I had 6% here. And I had 4% here. And I'm doing cumulative percentages. Actually, let's make this one. So in this case, my last one, I had 99%, even if I was at 98%. The rule is for cumulative rounded percent, you always round up the last one in the percentages closest to the cumulative amount. So to get to 100%, I would round this one up only under the scope of cumulative rounded percentage. The last number closest to the total gets rounded up or down so that we get 100% if we have an issue with rounding up to that point. Does that make sense? Can I explain it a better way, give you guys a better example? Give me thumbs up, thumbs down. I can totally explain that again or give you another example. But that's just what the rule is. Like I said, this one was nice and neat, so you don't have to apply that rule. Thumbs up, thumbs down, questions, thoughts, concerns. You want me to reiterate? Break it
So
down.
how do we get the cumulative rounded percent? What do we need to add or times?
Oh, the cumulative rounded percentage, you add up all the rounded percentages, and that's your cumulative rounded percentage. But you can't have over 100%. So the way you address that is when you're adding all your rounded percentages together, the last one in the group of numbers, right before you get up to 100%, that is the one you round up or round down so you get to 100%. You don't exceed 100%. Like, that's just what the rule is. Like, sometimes with math, that's something to, and you might have heard this before. Sometimes with math, when you're like, well, that's kind of unusual, I don't get that rule. Sometimes they take a Band-Aid and they just make a blanket rule in math. Sometimes that's what they do. Like 0 divided by 0. You don't really divide 0 by 0, but it's always 0 because that kind of makes sense. So with the percentages, the cumulative rounded percentage is the accumulation or the summation, another way to say it, of all your rounded percentages. But if you round up too much, like let's just say these weren't nice and neat in this scenario, and we had a couple percentages that got us to our cumulative rounded percent over that 100%, then the percentage right before getting to the 100% is the one that we round down or round up accordingly, so that the cumulative rounded percentages make sense because we can't exceed 100%. Does that help? I think Ryan got it, but I want you all to get it. Like, I can't really tell you why that's the rule, but I can tell you that that is the rule. I could certainly find out who the group of the mathematicians that makes that rule and tell them that we don't like that rule and maybe they should think about it and change it. But that's the rule as it stands. Let's go ahead and look at the next thing. So the next thing it asks us to do are hand calculations and simple frequency distribution and graph data. So you guys could look at this page 80. There is an example, and I'll show you something kind of cool with Excel in terms of how you might be able to see this a little bit clearer. Double check. I'll give you a page number in just a second to give you sort of a visual representation. I'm referencing the paper textbook, but in terms of what that's actually saying, so you understand what it's asking you to do, let me give you just a page number. Just that. That was 35. Page. All right, then maybe a really good graph, and I can totally draw this on the whiteboard too. I just want to give you something to cross reference, guys. Yeah, 60, not 80, 60. Page 60 to 61. I'll draw that for the user that may have an electronic textbook. Okay, so the example that's used to talk about simple frequency distribution in our book looks something like this. Let me go ahead and erase this, and then I'll draw it for you guys to give you a sense if you don't have like the paper textbook and that thing and that pages to refer to. So if we take and so in the book, what they give us is, for those of you that don't have it, they talk about the number of naps. Okay, so what they have two things when we think about simple frequency distribution. They have number the tic-tac-toe of naps. Now, as we all have become adults, I'm quite sure when we were kids, we did not like our number of naps. But as we become adults, we think naps are like one of the coolest things ever invented. I know I certainly do. So let's go ahead and just draw this out. So 0, 1, 2, and we'll add maybe just one more column. So number of naps, we have 0, 1, 2, 3, 4. And then the frequency of the thing happening. So like we have 0 occurring 8 times. We have 1 occurring 8 times. That's what we're talking about. We talk about frequency distribution, literally how the frequency of the thing, of the value, this is your value over here on your left-hand side, is distributed. So I know maybe new vocabulary or something you maybe haven't heard a whole bunch, the frequency distribution. How do I distribute the things that are happening? Now, I got a better example might be if you have a product that you sell, how frequently you sell that type of product in the real world. And then you could actually use this to like chart sales or have realistic results and things of that nature. And as we get down the road, if anybody wants to think about this, which I'm not going to teach this piece of this tonight, there's also something called linear regression where you can actually look at previous performance and then decide, or previous sales and decide what's likely to happen. Amazon does an amazing job with that. If you ever order something at like 6 in the morning and you go to work and you come home and you do two-day shipping and it's there and you practically trip over it, that's because they have an algorithm based on previous order history and they stock the warehouses accordingly. And they expect someone in your area to order the thing that you want in advance. And it's actually a pretty simple algorithm, but it's sort of a predictive model. But as you as you think about stats now, you might use it in the real world. You can get into predictive models. A lot of times you use linear regression, but tonight we're going to focus on what simple frequency distribution is. So on that page, on page 60, what they did is they went ahead and they put this on like your average, X and Y axis that you probably all saw from algebra when you were younger. So we have 0 naps. So this was frequency. This was actually the frequency at the time the thing happened. It was on our X right here. And then we had the number of naps on the Y for frequency distribution. And let me just write that so if you are following along or you step away for a second, this is your frequency. And we are doing just fine, by the way, on time, guys. We're right around chapter 6, right kind of smack dab in the middle. And we're covering usually about 4 chapters a month, so we're still doing absolutely fine. If you're like, oh, wait, we're going to cover that other thing, we will, this class or the next. I just want to make sure things are as clear conceptually as possible for you guys. So we have the frequency. So we have 2, then we have 4, we have 6, we have 8, then we got 10, and then we got 12. 12, make that a little better. We have 14, and then we have 16. That goes on. And then the number of naps. We got 1 right here. We got 2, 3, 4. Okay. So then they are bar graphing that distribution. So they're saying, all right, well, if we, and they have 0 right here. They're saying on the 0, it occurs in terms of our bar graph up to 8 times. So that's what this looks like. And then of course they shade that in. And then if we go over to right where 1 is, we look at that 1, that also occurs 8 times. So we have a similar bar graph right here, okay? And then number 2, 15 times. So of course, this is going to be a larger bar graph, what it looks like graphically. And that's what it's asking you. It's asking you to talk about the frequency distribution on the first part of the hand calculations of assignment 4. And then the next one is 3, pretty easy. So that goes up to 8. So that's another bar graph like that, right? And then 4, which is 1, so that's going to be really small. This goes up halfway before we get to 2. Okay, and 2 would be right about here. So that's what we're talking about when we talk about frequency distribution. Now, you might say, well, he gave us all these numbers. Like, how can we even see them? Let me show you this really, really amazing thing if you wanted to get a sense of what that looks like. Give me just a second to do another screen share in terms of how you might count. Now, you can cross them out, but let me go ahead and just actually clear rules entire. Perfect. Okay, so let's do a new screen share. So now you're like, well, okay, we got all this data. Now what all this is that you're looking at right here is literally I cut and pasted this from the exam scores for the assignment 4. Hopefully everybody's with me. Give me a thumbs up, tell me, but that's literally cutting and pasting this raw data into Excel. Does that make sense to everybody? You guys with me? If I totally lost you, give me a thumbs up. That makes sense, right? Okay, cool. So what we want to look at is how many times does the value happen to get the X value, like on this other sheet here. So we want the value, which are literally the raw numbers in the data, and we want the frequency of the number of times it happens for a simple frequency distribution. Simple frequency. I'll just call both. It's frequency distribution. So if we go back and we look at Excel, okay, great, because we have these numbers. So like, I might want to know how often, 72 occurred. So if I go like this, I go format, conditional formatting, and I go new rule, format only values, format unique or duplicate values, format, and I don't know. Maybe you could give me a color, guys. Should we say green, blue? Say blue, okay. Say okay. Okay, it doesn't work. I have to do the whole sheet. All right, so we're gonna do the whole sheet. All right, so I'm gonna do the whole sheet and conditional formatting, new rule, format unique or duplicate values, format. I want a color to tell me, so I'm gonna say this blue. Say okay. All right, so those are all the recurring values. You might be like, well, that doesn't help me, Dr. Mack. I'm not gonna be able to figure this out because sure, you show me where all the values are that repeat, but which ones are they? Now, you can, of course, you can cross this out. You can highlight them. There's totally ways to do this that don't involve Excel. But if you wanted to count them, you can go Control F. So let's see 72. So we're going to find what? We're going to type in 72. You guys can see that. It's hopefully all making sense. So 72, that is our X. That is this right here. So if I was doing a chart, my first number, and I was doing a different frequency distribution, okay? I would have my X or my value, okay? X or my value. And I have my frequency of the thing happening, okay? So the first one, 72, which hopefully is still making sense to everybody. If it's not, tell me. So that's 72, right? All right, so we go back to our Excel. And how the heck do we make heads or tails of this? This doesn't make a lot of sense. All right, 72, find next. So we have 1, right? 1, 2, 3, 4. Find next. Oh, went back. So it's only 4. So now we know for our frequency distribution, and if we go back to our whiteboard, 72 occurs 4 times. So then I could literally repeat that on the next one. So the next value is, or like I said, you could put this on a sheet of paper and cross it out. Like either way it would work. I'm just giving you the Excel example. All right, what about 68? The value and the number of times that it happened. 68. Find next. 1. It's our first one because right that it found, okay. What's the next one? 2. What's the next one? 3. What's the next? Nope, back at the same one. So now we know for our frequency distribution for that occurs 3 times. So for my frequency distribution, I would write 68. 68 occurs 3 times. And then what you're doing is you're graphing that like that example. Give me some feedback. Do you want to walk through drawing that completely, or is that part of the assignment feeling pretty clear? I'm open to either, guys. I just want to know what makes the most sense for you. You want to walk through every one of them totally down? If you're like, hey, it's clicking, I'm going to go with consensus, not majority, consensus. So if you all agree this makes sense, we won't walk through it. If one of you says you want to walk through all of it, we will. It's no problem at all. It's
I
getting
just have
there?
a question. We have to draw this. Oh, we have to draw this graph.
Yeah, because that's what it's asking you to do. If you look at the assignment,
For nursing data, or is this still the college board scores?
no, it's nursing student data. Let me pull that up so you guys can look at that with me. Okay.
Oh yeah, we did this yesterday, didn't we?
We did SPSS.
So you don't want us to go through SPSS for the
Here's
nursing data?
here's SPSS, and then
Uh-huh.
it says hand calculations.
Oh, okay.
So I'm walking you guys through that. So this is number 1 right here. You can use SPSS to check it. Your SPSS should look about the same.
Okay.
So then the next thing, so like I said, you wouldn't mind walking through? Okay, so sure. So let's go ahead and go with walking through it. All right, so for the hand calculations, where is my whiteboard? Okay, so we have, so the next one would be, and I'm gonna actually have to, I don't wanna erase this, so we have some room here for everybody. So I would really do the table, and then I would draw it. It's going to make drawing it a heck of a lot easier because you just refer to the table that we have. So, in fact, I could actually, you know what I might do, guys? I might do that in Excel. Easier for you guys. All right. So, you guys can see my Excel, right? Share my Excel right now? Maybe not. Let's do, yes, I am, okay.
Yeah.
So what I'm gonna do is I'm just creating a second sheet here so that we have something we can cross-reference. So I'm gonna rename this and I'm gonna call it frequency distribution table, okay? So we have sheet one and we have our X or our value. And then we have our frequency of the thing happening. So what we had so far is we had you share whiteboard. We had the 72 4 times and the 68 3 times. So that's what I'm going to put in our Excel. And I'll do new share so you guys can see. 72 4 68 3. Okay. 72 and 68. It should be 4 and 3. So like number of times thing happens, and this is, or you could say time thing happens, or maybe occurs, just to think about this conceptually. And then this is going to be your just like your value. Okay, just to I'll wrap the text just so you guys sort of see that. Correct. Okay. So now you get the number of time the thing happens or occurs, frequency of X, X value, just to give you something to look at. All right. So now if we go back to sheet one, we got to do the next variable, right? 81. So we know now all these that are in white, by the way, guys, super easy to do because they're not highlighted. So at the end, we're going to know that all of these numbers happen one time. So all we're going to have to do is just move them one time. So let's do 81. So 81 is a repeating number. So let's do Control F. We're going to say 81. So 81 is 1, 2. We can actually do, what happens when we find all? Oh, so 1, 2, 3, 4, and we're back. So it's 4. Hopefully that's making sense to everybody. If it's not, or is, you can totally give me feedback. Please do that. So I just did E1, 4, like that. That is what that is our value, and the number of times the thing happens, the frequency. So we go back to the next one, and our next repeating number is 58. So we go 58. We know it's in there once. We go 1, 2, 3, 4. And is there a fifth one? 5. Yeah, so that happened 5 times, right? 1. Let me move it over here. 1, 2, 3, 4, 5. Those are different, and then it comes back. So 58, 5. So 58, our value that occurs or repeats itself 5 times. A practical example might be if you had repeat customers ordering the same product that were the same price. All right, so the next one that we know from what we did with the show placements is 65. So 65, let's see. So we know it's in there at least twice. So 65, go like that. We go 1, 2, 3, 4, and we're back at the same place. We know that's 4. So I'm gonna do 65. Okay. And then we go back to sheet 1. Okay. So now the next one's 70. So 70 happens at least twice. So 71, 2. So just twice because it's the same spot. Now let's see what happens when we do find all. Oh, we can do find all. So that's twice. So 72. 70, and that's 2. All right. So let's go back to, so 83. So let's go Control F for control find. And we want to do 83, right? That's the one that we're on. So let's go find all, and we have it in there twice, right? That's pretty easy. So we're going to go 83, 2, right? So 83, 2 times. All right, so then we have 74. Now, this one's not highlighted. This is the conditional rule we said we're showing me like a duplicate. There's no duplicate 74, so we know it's 74, 1. That's making sense? Please give me feedback. So 74, 1. Next one is 58. So we know 58 occurs more than once, so let's go 58. Let's go find all. And what do we have? Let's make this a little bit bigger. Count them. 1, 2, 3, 4, 5. So it's 5 times 58. So we put that in here. We go 58, shows up 5 times. All right, cool. All right, so now let's go to 36. Now 36 is not highlighted to be a duplicate. It's in the rule, so we know it's 36, 1. Number of times it occurs. 36 occurs just 1 time. All right. So let's go. And all right, next column. So 49, let's see, that occurs how many times? 49, find all, looks like 4 times. 49, 4. 49, 4 times. Just give us a little bit of space here. All right. Next one is 73. We know it occurs more than once, so let's go 73, find all, twice. So that's pretty easy. 73, 2. All right, so if we go back to Excel and we go 60, right? Okay. Now, if you cut and paste these, by the way, guys, and they look like crap, like they look like that, just make the column wider, okay? If you're following along with me. All right, so, because then you can see the numbers. So 60, find all, Control F for find. 1, 2, 3, 4, pretty easy. All right, so that's literally showing us the frequency. So that's the value and the frequency, because you just visually count the number of times. 64, that's pretty easy. 60, full. All right. Then next one is 59. So we take 59, find next. Actually, let's go 9, Control F, 9, Control F, find all. We got it in there twice, 59, 2, so it occurs twice. 59, 2. Okay, pretty easy. All right, 60. How many times does 60 occur? 60, find all, and what do we have? I'm going to make this bigger so you can count. Looks like that's 4 times, so 64. So I didn't have to do that again because we just did that one. So 93 and 32 is 1. 93, 1. 93, 1. 32, 1. 32. Now another thing that we can do as we're doing this, just so we can if I want, I can, wait. No. All right. So 61. All. All right. Pretty easy. That's pretty easy. 61. Now, something we might want to do just so that we are efficient here is 2, 1. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 full columns. So I have, what, 90 numbers? 91, 92, 93, 94, 95, 96 numbers. So I want to know if we have 96 numbers. So when we get to 98, then we know we've counted everything. Okay, so that's how we know we don't have to count anything. So 61, 49, I don't think we've done that one yet. So it's at 49. Find all 4 times. Here's the distribution table. 49 occurs 4 times. All right. 73. Don't think that one yet. 73. Find all. 73 is twice. But I want to make sure that we're super efficient here. So I'm going to do conditional formatting. I'm going to do new rule. Format only unique or duplicate values right there. I'm going to do format. I'll say purple. Now you might be like, well, why are you doing that? So that's why, because we don't want to count numbers more than once. Okay. So if I eliminate these, if I just eliminate this, here, see, now it's only in there once. Then if I eliminate this, it's only in there once. Then if I eliminate this, it's only in there once. Then I'm gonna do the same. I'm not gonna do the same. I'm not gonna do this with this because the number of times it occurs could vary. So now, as we go through this, Excel's gonna tell us we don't double count numbers. So if I get a purple color here, you can move on to the next one. So sheet 1, 63, so 70. So 60, right? So 73, so let's do 60. So I'm gonna type it here. We don't need to count it. So we can move on to the next one. Okay. 59, did we do that? Well, rather than trying to remember, just 59. Oh, we already did that one. Okay, well, let's move on to the next one. All right. 60. Now, I think we might have counted that, but let's just check. 60. Yep, we already counted 60, so let's move on to the next one. All right, how about 93? I think we did that one. 32, I think we're on 61 memory. So did we do 61 already? Yeah, we did, right? Yep. Okay, so move on to the next one. 49. I think we did that one, but we could check. We just go 49. Yep, we already did that one, so let's move on to the next one. 79. Oh, we did not do 79. So now let's actually spend the time on that one. So find and replace. Let's do 79. Find all. You got 4 times. 79, 4. So frequency distribution, 79, 4 times. Great. Now, 52. Did we do that one? Well, let's find out. Let's type it right here. No, we didn't do 52 yet. All right. 52. We know it occurs more than once. How many times? Find all. 4. Easy enough. Put that in our frequency distribution table. That occurs 4 times. All right, so let's go to the next one. 43. Well, clearly that only occurs once because it's white and we haven't colored it. So let's just put 43 right in there. So that's the right number. Give it 43. 1. Okay, cool. Next one is 52. Now I feel like we did that and I can see that we did that. If I typed it, it would tell me, but this is so clear, I'm just going to skip that. 71. I think we might have done it, but I'm going to double check. 71 is, nope, we have not done 71. All right, fair enough. 71, let's see how many times 71 occurs. Find all, 2. All right, easy enough. 71, 2 for the distribution. All right, 88. Well, we know 88 and 90 only occur once, so we know there's no need to check. So that's pretty easy. 88 and 90, so that's just 88, 90, and that's 1 and 1, pretty easy. Now we're not going to go up to 98 because it's the number of times the numbers occur. Actually, when the frequency gets to 98, that's when we're going to know this right here, the number of times the thing happens. We'll listen to the raw data and the numbers. Okay, so 39. Now we know 39 occurs more than once, but just so that we're efficient here, let's type 39. Okay, 39 doesn't give us purple, so we know that it's occurred more than once, so we'll plug it in here. 39. 39, fine. 4 times, pretty straightforward, all right. 39 4 times. Okay. 26. 49, I feel we might have done that one before, but let's double check. Yeah, we did that. So let's not do that. Let's go on to the next one. 89, I'm not sure. Let's see. 89. Nope, we did not. So we go here, plug in 89, and we go find all, and it shows up twice. So we're gonna see it again. If we don't remember, if we did that one, if we don't see it, we'll just use that rule to check. All right, so we're at 89, so 75. I think we did 75 before, but let's make sure. 75, no, we did not. Okay, see, good thing we checked. So 75 is how many times? 75 is find all. 75 is only once. Oh, we're on the wrong sheet, that's why. 75, find all. Twice, that makes sense. 5 divided by 2. All right, so next one, 62. All right, so we know that occurs more than once. Did we already do 62? We did not, because otherwise it would be purple. All right, so make sure you go to the right worksheet every time. 62. Find all frequency, number of times it occurs twice, pretty easy. 62 twice. All right. And now we have 57. We know it only occurs once. There's really no need to check. We could, but we don't need to. So we're going to go 57, frequency of the time thing occurring. 1, it would have been purple if it occurred more than once. 39, I feel like we've done 39. Yeah, we have. Check for good measure, but really not necessary. All right. So 39. So 42. Oh, we're right here. 39, 57, right? 57, 39. So 70. Pretty sure we did 70. Yep, we have. So we'll move on. 65. I think we did that, but we can double check. 5. No, we did not do 65. Good thing we have the check in place. 65. How many times does that occur? Find all 4 times. Beautiful. 65, 4 times. Done. All right. Next one, 58. I feel like we've typed 58 quite a few times. Clearly we have. I'm not going to use the check because I can see it visually. All right, 92 and 45. They're both occurring once. Easy enough. So that's going to be our frequency distribution right here. 92 and 45 once, and 45 once. Enough. All right. So 58 and 73, I feel like we typed those quite a bit. I know we've done 58 because I just saw it. Well, let's make sure we haven't skipped 73. 73, yep, we've already done that one. So that's easy enough, which means we can go right to these. Now, since these are white, and we know that they're only listed once, we can just take these right here, cut and paste, save ourselves a little bit of time. Like I said, if you see a weird thing with the row, just make your row wider. Here they are, okay. 1, 1, 1. Easy enough. I could certainly type this by hand too. It's the same idea. A little bit bigger, but still correct information. Right. So now we're down to 76. 65, I feel like we've done that one a lot, but we can double check. And clearly we have, so no need. All right. 40. Let's see if this is the first time we've seen 40. It is the first time we've seen 40. All right. So let's go take a look and let's do Control F. We're looking for 40. Find all. We got it in there twice. All right. Easy enough. 40 is frequency distributed twice. All right. Next one. So we just did 40, so 62, only 2 other columns to go, and we will have this table built. 2. Feel like we've seen that before. I'm going to double check. Totally have. Moving on. All right. 38. I feel like we've seen that a ton of times. I'm sort of visually scanning to see it. Let's see if I see it. 38, 38. You know, I don't see it. It's right off the top of my head, so I'm just going to type it real quick. Make sure. Nope, we have not seen 38 before. This is purple. So 38, let's see, is distributed or value distributed how many times? Find all, twice. All right, easy enough. Okay, next one. 54 is once, so we're just gonna literally put that in here. 54, boom, 1 time, easy enough. 79. Now, I think we've seen 79 a bunch, but we can certainly make sure we didn't miss it. Type 79. Yep, let's keep moving. All right, 77, we know it's once, so we put that right in our frequency distribution table. It's not going to give us enough color. We would if I was mistaken. All right, easy enough. All right, 59, pretty sure I've seen this number before, so I'll double check. 59, yep, let's move on. All right, 61, 39, 68, 56, 49. Pretty sure I have seen all of these numbers already, but I could just take all of them right there and check. Apparently, we have not seen any of these before. I'm going to type those because I want to make sure that the rule is working. 61. Yeah, we have seen 61 before. The rule doesn't work if you type and paste. So 61, we're going to leave that one alone. 39, I'm pretty sure we've seen that before. Let's double check. Yep, that's totally correct. 68, pretty sure we've seen that before, but we can double check. Yep, seen that before. 56. 56. No, haven't seen that before because, hey, the rule would have told us. All right, easy enough. So how many times does 56 occur? Take a look. 56. Find all. Just once. So we've seen 56 more than once. So find 56. Find all. Yeah, it's in there twice. Call it something wonky. Yeah, makes sense. 56 in there twice. Easy enough. All right. 49, I know I've seen that number, but I can make sure that I didn't miss it. Type it, yep, clearly, because the rule is telling me. All right, 46, I know it's only in there once, so all I gotta do is type 46 and put that in there one time. Easy enough. That's the raw data. All right, 81, I think we've seen this a ton, but we can double check. 81, yeah, we've got 1. All right, 40, I know we've seen that, but we just for competitor, yep, clearly we've seen that. 83. Yep, that one's done. All right. So we're not listening twice. 60 and 52. So I think we've done those. Yep. So we'll not do that one. 52. Nope. Already done that one. All right. 53 and 28. We know that's frequency distribution 1 because it's not colored in our raw data here. The rules. So 53 and 28. 53 is frequency 1 time, and 28 is frequency 1 time. So that's all making sense to you guys. All right, 65. I think we've seen that before, but we'll double check. 65. Yeah, we've seen it. All right. 48. Let's take a look. 48. No, we haven't seen 48 yet. So let's go into the other one. And yeah, twice. Okay. So 48 is on twice. All right. And then 37 and 78 are by themselves, right? So that's pretty easy. 37, 78, both frequency distributed once. That completes our frequency distribution table. I can certainly conditional format this again, make sure there's no unique or duplicate values, just sort of double check my work, but Excel is wonderful because it's calling the rows, so I'm just double checking. And I have no numbers that are identical, which means we've done all of them. Number of times this thing happens. Like I said, we should have 98, 96, right? So I want to make sure I didn't miss anything as I built this table. So we have one column, and we go all the way to 10 completely. And then we have a row, and then we have 1, 2, 3, 4, 5, 6, 7, 8 rows. So 10 times 8 is 80. 1, 2, 3, 4, 5, 6. So we should have 86. So that's like what our n should be. So if I want to take all of this right here, move this out of the way, I take all of this and just move this down, and I sum this. Let's see if we made any. We miss any of the numbers. What do we have? Sum 91. Does that make sense? Count anything twice? Sure, we didn't count anything twice. Sheet 1, 2, 3, 4, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. To try to count a column 90, 91, 92, 93, 94, 95, 96. But they didn't all occur. Yeah, that makes sense because it's below. Because it wouldn't be above. It'd be that there's only these occurred twice and these occurred 4 times. So yeah, so that should be all of our numbers. So that's our frequency distribution table. Now, if we wanted to make it, nice and beautiful, we could just literally take like this, or you like literally draw this on a sheet of paper, and you just take and you could do all borders. Boom, now we got a really beautiful table. Pretty easy. All right, so that was what that asked us to do. All right, so simple frequency distribution graph data. We are literally right here. We need to graph the data. So now you want to draw this out. So we wanted to, we could take all these and we could totally sort from smallest to largest, and then expand this section because I want the frequency to move with it. So this is more like in order in terms of what we did. Same thing. So now if we want to make a graph, you could draw this out like the example that I gave you guys, and you really should, but if I'm just showing what this looks like, we would go data.
We can't see Excel.
Oh, sorry. Thank you. So graph data. Well, I think at this point, it might be easier if we just went ahead and imported this into SPSS. So I'm just going to delete this and that, and I'll share that back with you guys. Screen 2, share, and maybe we'll sort. Okay. I'm going to delete this column just because I want a nice clean graph. Let's go File. Let's save as. Let's think of a place where you can easily find it. Browse. And let's call this frequency distribution. And I'm going to save an Excel workbook now. If SPS doesn't like it, we'll come back here and maybe we'll save it as a comment delimited. Now, if you're saving this and you're following along with me, just to get a sense of how to import into SPSS, you just want to make sure it's in a place you can remember that it's in. So like maybe I'll save it in my OneDrive because maybe I can find it easier that way. For solid processing, saving the file, pretty straightforward, pretty easy. All right, so then let's do a new share. I'm totally going to get SPSS mad at me. Just a second. It's not like you sharing at all. Hopefully you guys can see my SPSS. I hope, right? Looks like you can on the other screen. Pretty sure you guys can see that. So I'm gonna apply this. All right, so now we got a blank file here. Go file, import data. And why don't we import Excel? That's what we're just looking at, right? I'll import data. We're gonna permit all access if you have any sort of restrictions. Now I saved it under my OneDrive. I want to be able to find it. So I'm gonna go back really far out here as we can go. All right, so maybe it's on this PC. Disk. No, it's not really showing up as easily as I would like it to. All right, so what I'll do is I will stop the share. I'll start a new share. Let's go back. Excel, let's think of a better place that I can save it. Let's save it, file, save a copy. Let's see, I went out OneDrive, let's browse. Browse, I'll tell this thing to browse. Distribution, and gosh, let's save this. Or would be easy to find. Oh, well, I was able to find Windows earlier pretty easily. So do that. And I put it was old. Yeah, do that. Excel workbook, so I can find it. All right, so now let's go to new share. We'll go back to SPSS, which I think he's showing you, or it will in just a second. Okay. All right, so let's go ahead and find that file. So I think I was on documents. Oh, Windows old. All right, that's where I saved it, so I can find that. Why can't I see it? So users. Me. All right. Save the file again. Like I said, you just got to play with the path sometimes so you can find it. Let's try browse. Downloads. Distribution. Save. All right. Yes. Documents. Okay, I literally just save that. It should pull up here. All right, well, we're waiting for that. So basically what you're going to do for the hand calculations part is you take your frequency distribution table, and then you would literally put your X and your Y. So we would have you would have your number of your thing happening. So like your value that we did right here, you would put that here, and then you'd have your X, or you'd have your frequency down your left side, and then you would literally just draw a bar graph based on what the data right here looks like. So you would do that. Now, if like I said, you can sort it, probably easier to draw the graph that way. If I sort smallest to largest, I want to expand the section. So I would start with, I'd do 28. The frequency of the thing happening would be 1. So for example, my first one on this, it would look like whiteboard. So the first one would be 28. It would be, yeah, the number of the thing happening would be 28. That's the, and then this would be smaller. If I had 1, I would draw this, okay, and then I should maybe shade the bar graph. And then my next number, I would go back to my frequency distribution, the nice table that I built, and I go, okay, the next thing is 32, happens 1 time. So I would do all of those, and the bar graph would get bigger as we went. So 32, and for example, so we go whiteboard. So the next number is 32. So that's also going to be the same graph, because still the frequency still only happening 32 1 time, and then as we went on, we would just do the next one. So like, let's say this would be frequency 2, for example. So the graph right there, you would shade in the graph, and for example, this one might be, for example, in your cell as you're drawing it, like if maybe maybe this one's so like 32 is 1, maybe 38 is 2 times, so that would be 38, and so on. So like this would look like, so this 38. I just pulled it. Hopefully that's making sense, guys. That is that step. Let me see if any more luck. So you follow the steps and you can import what I said right into SPSS without having to type it by hand. For some reason, my SPS is moving slow tonight, so we'll keep moving on this other parts of the assignment. New share, class assignment. Now we did simple frequency distribution, graph data. Now we're going to do the 3 measures of central tendency, mean, mode, and standard deviation. So we'd want to look at our formulas, right? So central tendency, mean, mode. So the mean, remember, is like the average. So share the screen again, guys. So we want to do the mean. So that's, so the mean right here. See your, okay, looks like you guys can see that. Perfect. So we're going to use this formula. So we want to find the sum of all the numbers divided by n. So if we go into our nice frequency distribution table that we built here, we want the sum of everything over the n, right? So what we're going to do is the sum of x, which is our value, over n, the number of times the thing happens. So we're going to take all our values and sum. So we have 28, 2. and the number of times the thing happens, or sum that, or our n, or like our population. So we sum that, that is 91. So 2862 divided by 91. What is our average? So, right. Math, just a little bit check the math here, guys. Oh, that's right. Yeah. So we take, I'll do the whiteboard here. So we're doing the sum. So we know that our average or our mean is the sum of our x values over our n's. We know the sum is 2862 divided by 91. 91. That equals, so sum of all the numbers, that makes sense. Divided by 91 times their occurring, 31.45. Our mean or our average. Okay, so that's the first part. We wanted to figure out what the mean was. Next thing it asks us is what the mode is. So now we want to look at how many times a number occurs. So 4 times seems to be the most, because remember the mode is the thing that occurs the most. So 39. Oh, I don't think you can see this. So the mode is the most frequently occurring number. And we can have more than one mode. That's totally okay. A lot of times you don't, you also can. So I know in my frequency, the number of times the thing occurs, I know just by visually looking that 4 is the number one mode. So if I'm looking for modes, we got 39, 49, 52. No, you know what? We have 58's the mode because there's a 5. Is the number that occurs the most frequently. So that was my bad because I didn't see 5. So now we want to find frequency that occurs the number 5 times, so the mode. So we got 5 once. Okay, do we have another 5 in here? I don't see another 5. So 58 is the mode because 58 occurs 5 times. So that's the next thing that it's asking you. It's asking you on the in-class assignment, the mean, mode, and standard deviation. So the last thing is the standard deviation for number 2. So if we go back to our formulas, what is standard deviation? So standard deviation is this formula, although I believe our book has a better version of that. I'll give you a page number. Again, I'll write it on the whiteboard in just a second, guys. I feel like there's a more clearer way to look at that standard deviation. So the 20, I believe standard deviation is, if you guys remember, I'll write that. Standard deviation, and this is coming off page 123. Let me go ahead and erase this just so we have a little bit more room. There's 2 formulas for standard deviation, right? So we have population, standard deviation. And that is the following format. Theta is u square root theta over 2, or another way to think about this is equal to the square root of the sum of the squares over n. So we should go back to Excel and figure out the sum of the squares over n, right? So we know, I believe, is it n91? So we have. And what is the sum of the squares? Now, if you look at page 122 in our textbook, that might give you a sense of what the sum of the squares are. Go into Excel, and we'll go ahead. So first we compute the variance, and then we take the square root of that answer. So we can start with the variance and sort of work backwards here, guys. So what is the variance? The variance is going to be either place to reference here. Computational, yeah, the sum of the squares over n minus 1. Yeah, the sum of the squares. So, okay, we go into distribution, Excel, share. So this is our x value. So we want the sum of the squares. So we want to square all these. Okay, so this is, these are our squares. So this is equal to b squared to the second power. So let's square all of these. So we're going to move this away. Square all those. And then we need the sum of the squares. That's pretty straightforward, guys. So we're going to literally sum all of these. So what's the sum of the squares? Sum. So that's that. And then the formula that we're looking for is the sum of the squares over the population, and then the square root of that. So let's go back to our whiteboard. So we have the square root, the sum of the squares, which is 196,888. So 196,88 over 91, and then we're going to take the square root of that. So you have a scientific calculator. Can someone give me that answer? I'll also double check your math right now. I'll pull up my scientific calculator as well. And then that is our standard deviation. I believe it was in the assignment. Oh, we did the standard deviation. And variability is the sum of so yeah, the variance, yeah. So first number is, so we're going to say 196, 888 divided by 91. That's our variance, which is 2163. So this, which is our variance, is 2163.6044. I write that down here. 2163.6044. And then we want to do the square root of that for our standard deviation. So by itself is a variance. So can someone tell me the square root of this? Put that into your scientific calculator. Maybe put it in the chat. Scientific calculator. So square root of 2163.6. That is 46.51, which is our standard deviation, which absolutely makes sense. So that means our standard deviation is equal to 46.51. I'm just going to do 2 decimal places. So that is 46.51 is our standard deviation. So we did the standard deviation, we did the mean, the mode, the actual standard deviation again. And then in the variability, we did that too, because that is this number before we do the square root, so that's your variability. And the last one is the range. Remember the range from last week was, the range is always the high minus the low. So if we go back into this right here, well, we know, because we sorted these, our highest one is 94, and our lowest is 28. So that would be our range. So I have, yeah, you got it. Perfect, Yesenia. So if we take 94 minus 28, what is our range? Can someone write that or put that in the chat for me? I'll check your math too, no problem. So 94 minus 28 is equal to, and we have an answer, 66. Yeah, perfect. So those are the hand calculations. I know it's a lot of work, but that does complete it. And we did do the SPSS in the previous class where we literally put the data in and then asked for it to give us the output. So I think we'll call it a day on that because we can do some other worksheet stuff. But we're almost at time, and I know you guys have been working hard. So hopefully that answers all your questions on assignment 3 and 4. Really made assignment 3 and 4 clearer for anybody that asked or anybody that was afraid to ask. But that should give you a sense of what to do. And then, like I said, the SPSS we did in the previous class right at the end for that is, again, assignment questions, thoughts, concerns, anything you want to run by me before I shut off the recording, guys. I think I'll let you go a few minutes early because you guys did an amazing night, stayed engaged. Questions, thoughts, concerns before I dismiss you guys. No. Okay. So I am going to assign, I'll put this in Blackboard. Something that I always do as a best practice is whenever I assign something, I put it in Blackboard. It's usually the same day. It should be today. I might have to run out and do something with my wife temporarily, but I should be able to before like midnight, like very soon. Post that. If for some reason I don't post first thing in the morning. So web assign 6, pre-test 6, post-test 6, all due in a week. I'll give you guys all the way through the next Wednesday at midnight. You get 6 attempts, take the highest score. If you're missing anything, you should definitely reach out to me. Hopefully the hand calculations are making a lot more sense to you. And really, when you're doing this, guys, think through what it's asking, like the sum of the squares. What is the sum of the squares? Like just really, really break it down, and then it can become a lot clearer and a lot easier for you guys to do. I hope that helped. I hope you learned something today. Hope you enjoyed the class. I certainly did. I'll see you all in about a week. I think you all have my new phone number. I posted that in the chat, actually in the announcements. So just email me, call me. And by the way, a couple of you that emailed me, a couple of you did show your hand calculations and they were way down. I thought they were on the worksheet. If you've emailed me because you had a question about your grade, I'm going to respond one by one and adjust Blackboard accordingly. So if you did show your work and I didn't see it for some reason because it was way down there on the sheet or Blackboard loaded funny, I'm going to review all those emails and I'll be responding to you. So if it's in there and for some reason I missed it because of Blackboard doing something or only showing me like the worksheet and not actually the work below or something, which Blackboard occasionally does, I will go ahead and correct it in the beginning with the points on that. So no worries there, guys. Other than that, have a wonderful night.